are going to be talking about how to calculate the average atomic mass. So just to kind of go over what we have gone over so far, we have gone over density, we've gone over combination ratios, isotopic symbols, periodic table, calculating molecular weight we will go over in a future video. Average atomic mass is what we're doing today. Sig figs we've gone over. We need to go over balancing equations, stoic number moles mass, and we have gone over accuracy / precision. So we are slowly but surely getting there. We are definitely about halfway through, I would say. But yes, so let's talk about why we calculate the average atomic mass, right? So the reason why we calculate the average atomic mass is because there are things called isotopes. And what isotopes basically are is that they are elements of the same element, basically, with a different number of protons, or different number of neutrons, because the number of protons tells you what element it is. Oh my goodness, neutrons. There we go. Elements of the same element with different number of neutrons, or I guess you'd say atoms of the same element with different, whatever you want to call it, right? So here's an example. Carbon 14, carbon 13, and carbon 12. What this tells us is that this carbon weighs 14. So we know that carbon has 6 protons. So protons is 6. And we know from a few videos ago, in order to find the number of neutrons, you just take the mass, which it's telling us here is 14. So it's always going to be the element, and then this is the mass. So 14 minus 6, we know that there is going to be 8 neutrons. Next one. Proton's always going to be 6 because it's carbon. And we can do that from the periodic table, by the way. So, you don't have to memorize that. But this is from the periodic table. 13 minus 6, number of neutrons is 7. Next one, protons. There's 6 protons, as there always will be. And the number of neutrons, 12 minus 6, is 6. So you can see here, this just is the different number of neutrons that are present in each of these, which makes the mass different. During these calculations, we're going to be given the percent abundance of something, so then we can calculate the average mass, right? So let's say that carbon 14's pink. Maybe we have carbon that's blue. Carbon 14's blue, and then we'll make one of them green. We'll make carbon 12 green, right? So let's say that we have about 25% of carbon 12, right? So let's do, we'll do a few of those in there we'll make it kind of look like 25, right? And then here we have carbon 14. We'll say that there's another 25% of that. These aren't the real numbers, but I'm just doing this for reference. So that would be more than 25%. All right, so we have 4 and 4. And then let's say we have carbon 13. I'm just doing this as a visual, so this is not something you will have to do. But we'll say carbon 13 has 50%, because that makes 100%. 1, 2, 3, 4, 5, 6, 7, 8, right? So in this little section of carbons, in a total of, let's say, what is that? That would be 16 carbons. You're going to have 25% of them weigh 14. Another 25% is going to weigh 12. And then 50% of them are going to weigh 13. So what we have to do is we have to figure out the average mass based on these things, right? And how we find that is using this equation. The average mass is going to be equal to the, we'll say, mass of 1 times the percent of 1, plus the mass of 2 times the percent of 2, plus the mass of 3 times the percent of 3. right? So average is going to be equal, in this situation, the mass of 1 is 14, and the percent is 0.25. So just to keep in mind, when you're doing percents, you always move the decimal place over 2 times to turn it into a decimal. So we have to turn it into a decimal. All right, next one, mass of 2 is 12, and we have 25% of that, plus mass of 3 is 13, and we have 50% of that. All right, so you put that into your calculator. You do 14 times 0.25 plus 12 times 0.25 plus 13 times 0.50, you could say. And the average is actually going to be 13. So AMU, by the way, this is all in AMU. So that would be the answer for that, right? So you're just really using this equation and the amount that you're given to give you the answer of the average. So I'm going to give you guys a practice problem in there. So we'll write this down as practice. So let's say that you have, I'll just do a random element. There's, let's do Z, right? Z isn't actually an element on the periodic table, at least I don't think so, but we're just going to use this as kind of like a practice one. So let's say we have Z 37, we have Z 35, and then we have Z, we'll do 39, right? And let's give these some percent abundances. So let's say we have 29% this, we have 5% this one, and then 29 plus 5 minus 100, we have 66% of the Z39. So what you want to find from this is find the average atomic mass units from this, using that same equation that we had before. So if you guys would like to pause the video and try that out yourself, I will be doing this problem in 3, 2, 1. Okay, so mass of the first one is 37, the percent is 29, plus 35, and the percent is 0.05, plus 39, and the percent is 0.66. So I'll put that into my calculator. 37 times 0.29 plus 35 times 0.05 plus 39 times 0.66. Cool, so what we get as an answer here is 38.22 atomic mass units. And that would be our answer right there. Okay, another thing I want to look at is how we can determine, based on like our best guess of what something's going to be, based on just like a few parameters that they give us, right? So let's say that we have that same element Z, and we're told that the average atomic mass units is 80, right? Average atomic mass units is 80. And we're also told that the isotopes they weigh Z79 and Z81. This is similar to one that Professor Sherlock gave. But if you had to estimate based off of this, what do you think the percentage of these would be, right? So this one's pretty simple. If you think about this, we're kind of just taking the mean, but in an opposite way, you know. But if the average is 80, and the other two numbers are 79 and 81, what do you think that those percentages are going to be? So the percentages are going to be 50-50. At least they're going to be close to 50-50, right? Because 80 is in between 79 and 81. And if we were to do this, if we were to do 0.5 times 79 plus 81 times 0.5, we would get 80. And that's just looking at it as kind of like an analytical view. But that might be something that he has you do on the test, is predicting the mass of something based off of the percentages that are given. I'll do one more practice with that one. So let's say we have Z90, we'll do 95, and then we'll do Z 99. No, we won't do 99. We'll do Z 91. All right. So let's say that Z90 has a 90% abundance. Z91 has a 9% abundance, and 95 has a 1% abundance. So you know this one isn't going to affect the mass much. This is going to affect it a lot because there's 90% of it, so we know that it's going to be somewhere around 90. This is going to have a really small effect on it, and this is also going to have a relatively small effect on it. So I'm just going to put a guess in there that maybe it's going to be around 90.5, right? For the average mass, right? I did this wrong. I did that very wrong. Okay, so let's say that we are given Z has an average atomic mass of 91.2 AMU. So, and we're also given that the numbers are 91 and we'll say 100. We'll make it a big number. You can assume that there's going to be a lot more of this. So I'm just going to put a guess at like 90% and 10%. It doesn't have to be exactly right, but you just have to know that like this is going to be way more abundant because that's the average atomic mass, right? If it was something closer to 100, we know that 100 would probably be the more abundant one. And then you would just flip these numbers. But yeah, so that's kind of all of the things I want to talk about when we're talking about average atomic mass. Definitely, I would suggest doing some practice on it because using that equation and then also doing the thing where you have to like guess the amount that you think it would be. But the next thing that we are going to be talking about is doing some molecular rate. So we're going to be talking about molecular rate in the next video. So I hope this helps, and thank you all for watching.